Hello. Welcome you all into this lecture. In this lecture, we will discuss about the important topic about the geometry and the shape of the molecule. The geometry and the shape. Some student feels very difficulty to differentiate between the geometry and the shape of molecule. So in this lecture, I will tells about the difference between what will be the geometry and what will be the shape of the molecule. The geometry is basically drawn on the 2D paper, but the shape is the real observation. The geometry includes the bond pair plus lone pair, but the shape includes the only bond pair, not the lone pair. How can we differentiate between these two terms? So if any molecule or the structure of the compound is given, then how can we determine about the geometry and the shape? For this, first of all, the molecule steric number has been calculated, and then from this we will go to the hybridization of the molecule, and then we go to the geometry, and after that we will tell about the shape of the molecule. If the steric number is the 2, then hybridization of the molecule will be sp. So the geometry corresponding to this hybridization will be linear and the shape will be linear. Similarly, if the steric number is 3, then hybridization of the molecule will be sp2 and the geometry trigonal planar and the shape trigonal planar. If the steric number is 4, then hybridization is sp3, then geometry will be tetrahedral, then shape may be tetrahedral. If only bond pair is present, no lone pair is present on that molecule. But if one lone pair is present and 3 bond pair is there, then the shape of the molecule will be pyramidal. If the 2 bond pair and 2 lone pair are present in the molecule structure, then we can say that the shape of the molecule will be V shape or band shape. Similarly, if the steric number is 5, then hybridization of the molecule will be sp3d and the geometry will be trigonal bipyramidal, and it is represented by TBP. So shape of the molecule, there are many cases for that. The geometry, if the trigonal bipyramidal, then shape may be TBP, seesaw, T-shape and linear. In case of TBP, there will be 5 bond pair and 0 lone pair, and if 4 bond pair plus 1 lone pair is present, then the shape of the molecule corresponding to the geometry of trigonal bipyramidal, the shape will be of seesaw. If the 3 bond pair plus 2 lone pair are present, then the shape of the molecule will be T-shape. If 2 bond pair plus 3 lone pair are present, then the shape corresponding to this will be linear. For example, if we consider the CH4 molecule, then its steric number is 4. Steric number is 4. So the geometry of this molecule will be tetrahedral, and the shape of CH4 is also tetrahedral. But if we consider the example NH3, then NH3 steric number is also 4 and its geometry is tetrahedral, but the shape of the NH3 is pyramidal, because in NH3 molecule there are 3 bond pair and 1 lone pair. H2O. In H2O, the steric number is also 4 and the geometry of this H2O molecule is tetrahedral, but the shape of H2O molecule is V shape. Because in H2O the oxygen atom contains 2 lone pair and 2 bond pair, so it is the case which is 2 bond pair plus 2 lone pair and steric number 4, so its shape will be V shape or band shape. Calculation of steric number. So steric number can be calculated by 2 methods, if the structure is given and if the molecule is given. In the case of structure, the steric number will be number of sigma bond plus lone pair. In the case of molecule. If the molecule is given, then how we can calculate the steric number? So formula is 1 by 2 V plus M minus C plus A. V represent the number of valence electron, and M represent the monovalent atom, and C represent the cationic charge, and A represent the anionic charge. Example, allene. In case of allene, the structure of allene is like this. There is one hydrogen and this hydrogen. If we consider the carbon number 1 and the second and the third. So for first carbon, the geometry around this carbon can be calculated. How? So first of all, we calculate the steric number. Steric number is number of sigma bond. The number of sigma bond around this carbon. So one sigma bond, this is one sigma bond, and this is one sigma bond. In two bonds, there is only one sigma bond and the other is pi bond. So how we calculate? The number of sigma bond is 3, but there is no lone pair. So the hybridization of this carbon will be sp2. So geometry will be planar. Geometry will be planar. If we talk about the second carbon, so for the second carbon, the steric number will be number of sigma bond. So only one sigma bond and the other is here sigma bond. So only two sigma bond. The others bonds will be considered as the pi bond. So the steric number will be 2. So the hybridization corresponding to this will be sp, and the shape or geometry will be linear. If we talk about the third carbon, it is similar to the first carbon. So there are only 3 sigma bond. So one sigma bond and this is one sigma bond. So the steric number will be 3 here, and the hybridization will be sp2 and the geometry will be planar. If we talk about the molecule, if the molecule is given, then how can we calculate? So for that, if the example is given is like that, for example BF3. In case of BF3, the steric number can be calculated as 1 by 2. So V, number of valence electron on the central atom, number of valence electron on the central atom. So boron has 3 electron. So there will be 3. And number of monovalent atom, there are 3 monovalent atom. So this is 3. So steric number will be 3 or 3, 6 divided by 2 is equal to 3. So the geometry is planar and shape will also be planar because there are no lone pair. How we can calculate the lone pair? So for the calculation of lone pair, we will use the formula lone pair is equal to steric number minus side atom. Steric number minus side atom. For example, if we consider as benzene, so then benzene is C6H6. The geometry of benzene is like this, as you all know very well. So in the benzene there are 6 carbon atom here and 1 hydrogen are present on the each carbon atom. So the geometry corresponding to this carbon atom will be, there are 1 sigma bond, 1 sigma bond and 1 sigma bond. So there are 3 sigma bond. So the steric number for this carbon atom will be 3. And the geometry corresponding to this will be planar. Similarly, in that carbon atom, there are 3 sigma bond, 1 sigma bond, 2 sigma bond, there are 3 sigma bond. So the steric number will be 3 and the hybridization corresponding to this will be sp2 and the geometry will be planar. Similarly, for that carbon atom, there are 3 sigma bond. So steric number will be 3 and hybridization will be sp2 and the geometry will be planar. It's okay. If we talk about the another example of the molecules, NO2 positive. Then if the molecule is given, then steric number will be equal to 1 by 2 number of valence electron. So central atom is nitrogen, so number of valence electron of nitrogen is 5 plus monovalent atom. If is there oxygen monovalent atom? No, oxygen is divalent atom. So if the divalent atom are given, for example divalent atom or trivalent atom are given, then we will not consider for the calculation of steric number. For example, divalent atom are oxygen and trivalent atom is nitrogen. So we will not calculate in the steric number calculation. So there are only 5 for the nitrogen and oxygen is divalent atom, so we will consider as 0 because it is not the monovalent atom, but the cationic charge is 1. So 1 cationic charge plus, is there any anionic charge? No anionic charge, so there will be 0. So calculation 5 minus 1 is 4, 4 divided by 2 is 2. 2 means hybridization will be sp. So the geometry corresponding to this hybridization will be linear. So to identify the shape of the molecule, we can calculate easily number of lone pair as the formula is given in the previous slide. So how we calculate the lone pair? The lone pair formula was steric number minus number of side atom. So steric number is 2 and the number of side atom are 2. Because the side atom oxygen is 2, so there will be 2 minus 2 is equal to 0. So no lone pair is present on the central nitrogen atom. So okay, so 0 lone pair and 2 bond pair, so the shape will be linear. And in the case of linear shape, linear geometry, the shape is also linear. If we talk about the example PCl3, steric number will be calculated as the second method. Steric number is equal to 1 by 2 valence, number of valence electron. So phosphorus is 2, 8 and 5 because it is 15 atomic number element, so there are 5 valence electron. So 5 plus number of monovalent atom. So number of monovalent atom are 3, so 3 minus, is there any cationic charge? No cationic charge, so there will be 0. And is there any positive or negative charge? Negative, there is no negative charge or anionic charge, so there will be 0. So 5 plus 3 is 8, 8 divided by 2 is 4. So the hybridization corresponding to this will be sp3, or corresponding to the sp3 there are, the geometry will be tetrahedral. So geometry will be tetrahedral because geometry is the bond pair plus lone pair, so geometry will be tetrahedral, but the shape can be different. So what will be the shape? So for the calculation of shape, we will calculate first of all the lone pair. So lone pair will be equal to steric number minus number of side atom. So lone pair can be calculated as steric number is 4 and the side atom there are 3. So 4 minus 3 is equal to 1. So 1 lone pair is present on the central phosphorus atom. So there are 1 lone pair. So it is the case of 1 lone pair and 3 bond pair because the steric number is 4. So 3 bond pair plus 1 lone pair. So 3 bond pair plus 1 lone pair means it is pyramidal shape. So the shape of PCl3 will be pyramidal. This is the shape of PCl3 molecule. The short trick to identify geometry and shape, because in exam there is lack availability of the time, so we will discuss about the short trick. So short trick is, for example, if the molecule H2O is given, then what will be the geometry and what will be the shape of H2O molecule. So in H2O molecule we will first of all calculate the number of valence electron. So number of valence electron on the oxygen atom is 6, so we will make the 6 cross 1 2 3 4 5 6. These are the valence electron 6, and in out of this 6 electron, 2 hydrogen make the sigma bond. So one sigma bond is made by this hydrogen and one sigma bond is made this hydrogen. So the rest electron will be considered as the lone pair. So number of sigma bond is 2 here. So there is one sigma bond and there is one sigma bond. It is the lone pair and this is the lone pair. So it is the case of 2 sigma bond and 2 lone pair. So 2 sigma bond and 2 lone pair means there is steric number is what? So steric number is 2 sigma bond plus 2 lone pair. So steric number is 4. So hybridization will be sp3, and the geometry will be what will be the geometry? Geometry will be tetrahedral because the steric number is 4. So geometry is tetrahedral. But the shape because the steric number is 4 and 2 sigma bond and 2 lone pair. So 2 sigma bond and 2 lone pair is the case. What will be the shape? It is V shape, because V shape consider 2 sigma bond and 2 lone pair. Similarly, if the examiner is asking about the geometry and the shape of the ClF2 positive, then how we can analyze? So for that, first of all, we calculate the steric number. So for that, the Cl atom is considered as the valence electron will be in the Cl, on the Cl atom will be 7, 1, 2, 3, 4, 5, 6 and the 7. There is one positive charge. Positive charge means the one electron has been removed from the chlorine atom. So the chlorine atom will contains in this case the 6 electron, because one electron is removed and the one positive charge has been observed on the Cl atom. So there are 6 electron, and out of these 6 electron, 2 fluorine atom make the sigma bond, one fluorine and the other one fluorine. So number of sigma bond, 1 sigma bond, 2 sigma bond, and the other will be considered as lone pair. So there are 2 lone pair. So steric number of this molecule will be 2 sigma bond plus 2 lone pair. So 2 sigma bond pair plus 2 lone pair. So 2 sigma bond pair plus 2 lone pair means 4 steric number. 4 steric number means sp3 hybridization, and so then the geometry, what will be the geometry? Geometry will be 4, corresponding to 4 geometry. It is tetrahedral, and to analyze the shape, the number of lone pair is 2. So in case of 2 sigma bond plus 2 lone pair, the shape will be V shape. It is similar to the H2O molecule. So the shape will be V shape, and it is like this: Cl, F, and this is F. 2 lone pair are present. It is V shape. There are another example. So how we find the geometry and shape? So for that, first of all, we will write the Cl valence electron. So how many valence electron in the Cl? There are 7 electron. 1, 2, 3, 4, 5, 6, 7. 6 and then 7. Is there any positive charge? No positive charge, and there is no negative charge. So there are 3 fluorine atom. 1, 2, and this is 3. So 3 fluorine atom means 3 sigma bond and 2 lone pair. There are 2 lone pair. So steric number will be 3 sigma bond pair plus 2 lone pair. So steric number will be equal to 5. So 5 means it is sp3d2, and geometry consider the sigma bond plus lone pair. So 5 means TBP, trigonal bipyramidal, TBP, and the shape is 3 sigma bond plus 2 lone pair means it is T shape. So its geometry will be like this: Cl, this is F, and this is 3F. It is T shape. It is like T shape. This is T. So Xg, the central atom is Xg, and the number of valence electron on the Xg are 8. 1, 2, 3, 4, 5, 6, 7 and 8. There are 3 oxygen atoms. So 1 the oxygen atom is divalent, so it is make one electron covalent bond, and another electron will make the another covalent bond. So there are two bonds will make the oxygen, and the second oxygen will make is like that, and the third oxygen will make the bond like that. So number of sigma bond, there is one sigma bond, and the oxygen atom the another bond will be pi bond. This is pi bond, and this is sigma bond, this is pi bond, this is sigma bond, and this is pi bond. So these will be considered as the lone pair. So number of sigma bond plus lone pair is steric number. So number of sigma bond, so there are 1 2 3. The pi number is not calculated, so there are 1 2 3 3 sigma bond plus 3 sigma bond pair plus 1 lone pair. So 3 sigma bond and 1 lone pair is equal to 4. So the hybridization will be sp3, so the geometry will be tetrahedral, and shape will be 3 sigma bond plus 1 lone pair means it is pyramidal, NH3 like. So its shape will be pyramidal and the geometry will be tetrahedral, and it will be like this, XgO3, and this one lone pair. So it was the concept of geometry and the shape. So thank you for watching this video.